Muted.
Okay, so as we discussed in the last session, we have different topologies available in Golden Gate. I mean, these are the various applications where we can make use of Golden Gate. One is unidirectional replication, second one is a bidirectional replication, third one is a pair-to-pair, and fourth one is a broadcast, and fifth one is the consolidation, sixth one is a cascading. So based on our business requirement, we will start making use of all wherever we required. Based on our requirement, we can make use of this any of these topologies. In case of reporting, we can make use of unidirectional replication or this topology. Otherwise, if we need high availability related configuration, we can make use of bidirectional, and load balancer or high availability, it's similar to the bidirectional, but it is one more node will be there here, that is a pair-to-pair. And just I would like to give you little details about all this. So the first one is unidirectional one. So basically what happens, this is the simplest we can say replication method available in the Golden Gate. So this is the one-way one-way replication. So data flows from only one direction, like it's a source to target. Oh, sorry, let me connect to my organizer also. Just I'm pausing the recording for a second.
Muted.
Yeah, we are discussing about the unidirectional replication. Basically what happens is that here also we will have source and target missions. Like we will have source and this is the target. So what happens is that always replication happens in only one direction. So for example, if we define this as a source, so automatically this will be target. So only data flows from here only. That all the transactions, whatever happening, all will happen on the source only, and this will be read-only session. I mean read-only database we can say. So what happens is that whatever the transactions happening on the source, those will be replicated on the target, and this target database will be in a read-only state. Not read, right? Read-only state. So basically what happens is that the target will be used for reporting purposes, and I think in the initial day also we discussed this scenario. In order to separate batch processing from the OLTP transactions, what we can do, we can segregate transactions into two. One is OLTP and another one is batch processing. All OLTP transactions would be performed on source, and all batch will be executing on target mission. So in this way we can separate the transactions so that we can have a less load on the OLTP. At the same time we can achieve whatever the output we are expecting from the target mission. So this is the common configuration, and it's the simplest one. And if you observe it, this is the same configuration will be used in almost all the configurations, whatever I mentioned, like bidirectional or peer-to-peer or consolidation or data integration, cascading or broadcast, wherever it may be. So ultimately we are going to use unidirectional replication only, but in a different combinations. So just let me explain each and every configuration one by one. And the same configuration, like a unidirectional configuration, also called as active-passive. This is about the unidirectional. And the next one is a bidirectional configuration. So if you see the bidirectional configuration, the same thing like unidirectional, but here we will have a two unidirectional in both the ways. Say for example, we have a source over here and target over here. So what happens is that we will configure one unidirectional over here, and the same way we will configure one more unidirectional from target to source. So what happens is users will keep performing the transactions from here also, and users continue to perform the transactions from here also. So what happens is that when users are performing the transactions from the source database, automatically those transactions will be replicated to the target machine. At the same time, we have configured another replication over here. So that is from target to source. So when users are performing some transactions over here, on the target, so those transactions will be replicated to the source. So using this replication. So what happens is that so users will continue to access both the machines, the source as well as target. At the same time, users can perform their operations, whatever the operations like we discussed, like DML operations. So those will be synchronized, replicated across both the machines. So this is similar to like we can say active configuration. But one of the main problem over here is that, not problem, one of the area where we have to focus over here is that there would be a conflict can occur. So we have to deploy conflict and resolution, conflict detection as well as resolution methods over here. Apart from that, there is no other issue. Suppose if we can able to deploy one good conflict detection as well as a resolution, so then there won't be any problem for this. So let me explain you a little more details about this one. I think this will give you more about, say for example, in unidirectional, what happens is that this is the source machine. So what happens, this is the source machine and this is the target machine. So whenever you need to configure a replication between these two, so what you will do, you will configure one local extract over here, that is on the source machine. So the main purpose of this local extract is it will keep monitoring the transaction logs generated by the source log, and it will send those transactions to the target machine, either direct method or through data pump. If you remember, this component is an optional component for us. Either the local extract can directly send to the target machine, or it can it can write into trial files, and after that data pump can send it to the target machine. So once the target file, trial files are available, like once it receives, the collector process on the target machine, what it does is that it collects the trial files from the, information from the source, and it writes them into remote trial files. This is the remote trial files. And replicate will, what it does is it will start replicating them to the target database. This is the main process happening in the unidirectional. Okay, whereas in bidirectional replication, okay, this is the diagram for bidirectional replication. So suppose if you see the lower part of this diagram closely, sorry, I'm not able to write properly. So suppose if you divide this entire diagram into two parts, one is a lower part, another one is upper part. Lower part is a one-way direction from source to target machine. So we configured a local extract over here, and we configured remote trial over here, and replicate over here. So what it does is the same thing, whatever we discussed in unidirectional, the same thing happening over here. So we have one extract in the source machine, and as an optional component we have a data pump component over here, and if at all if we need, and otherwise extract will send directly to the target machine, and replicate will replicate the transactions to the target machine. In the same way, there is a reverse replication also has been configured over here, that is from the target to the source, and we have the extract over here. Okay, and we have data pump as an optional component and the trial files also as an optional component over here. And this is a remote trial, and replicate we configured it on the source machine. So here, if you see, the bidirectional means it's nothing but combining two unidirectionals at both the ends. One is at source, another one is the target. So this is about the bidirectional. So what we did is that based on our requirement, we configured required components to achieve the business requirement. And third one is see, this is the broadcast replication. So what happens is that in the broadcast replication, we will have one source and more than one target will be there. So like, you know, broadcasting the message. What we can, how we will configure over here is, like in the source mission, all the transactions will take place in the source database, and target database will be in a read-only state. It keeps receiving the transactional changes from the source, and replicate process at the target will replicate the changes to the target machine. So in this configuration, what we are doing is just we are configuring one local extract in the source machine. It keeps monitoring the transactions, whatever happening on the source, and it will make them like, you know, in the form of trial files and data pump. I mean, here also data pump is an optional component, but let's assume the data pump is there, and the data pump will send the trial files to the respective target database. Say for example, I configured one data pump over here. So what it does is that it will send the trial files to its corresponding target. Say this data pump has been this data pump, like whatever over here, this data pump has been configured to send the trail files to this target database. I hope everybody is able to see my mouse pointer. So what happens is that whenever it collects any transaction changes, automatically it will push the you know, those corresponding changes to this target database. And we have configured another data pump over here. So those trail, I mean, what it does is that whenever it receives like any transactional changes, automatically it will push to its corresponding target database. So in this way, we can implement the broadcast, you know, broadcast method, broadcast replication over here. So basically, this is for, you know, data distribution. We will use this broadcast mechanism. Okay, like sending the data to more than one database. So that is the reason we will use broadcast. And another one is we haven't discussed about the peer-to-peer means the similar way broadcast. What is that? Peer-to mean it's nothing but a bidirectional replication only, but we will have more than two systems will be there. And the next one is consolidation. Okay, so if you see that here, consolidation means what happens is it's a reverse to the broadcast topology. So what will be happening over here is that here we will have more than one source database, but all the transaction, you know, but the target database will be only one. So we will configure extract on each source database, and it will generate a source trace files, and data pump will keep monitoring those trail files, and it will push those changes to the target machine. And in the target machine, one replicate will be configured for each source machine, so it will keep applying those changes to the target database. In a similar ways, for the other database also, we will have extract component, and local extract component will be there, and that extract component will keep monitoring the transactions, and it will push those changes to the same way how unidirectional is happening. So ultimately, what happens is that all the transactions will be applied to the same single target database, but there will be multiple databases over here. So these are all about a general one, and cascading is also there. Cascading is also similar to the same thing, just only the difference is that like, you know, Instead of configuring the local extract, what we can do is just we can have one more database over here. Let me show you that example. So this is the cascading. Cascading is also similar to the broadcast only the difference is that instead of taking place all the changes like collecting the extra, capturing the changes, configuring the capture, extract process will be configured on a different machine rather than in the source machine. So the transactions, whatever happening, those will be pushed to the another server. From here, extract will generate the trail files. So and after that, the rest of the configuration is same. Otherwise, we can configure extract over here, and those trails trail files will be pushed to the intermediate server. From there, rest of the configuration will happen the same way, however, happening in the broadcast. So this is about the different topologies. So the next section I'm going to discuss about it, Golden Gate installation. So before Golden Gate installation, just one of the configuration is very important configuration, that is supplemental logging. This is a most important concept which is very important over here. Without this we cannot replicate any changes from source to target database. So just I would like to spend a little time on this topic so that everybody will have an idea what exactly this is. This is a very simple concept, but just it's worth to spend some time on this. Let's say this is the source database over here, and this is the target database. So users are performing the transactions from here. So those will be recorded into the redo log buffer. From redo log buffer, the transactions will be replicated to, moved to online redo log files. From there, archive logs, the changes will be moved to archive logs. So this is the standard methodology, whatever happening over here. So, suppose in order to replicate, generally what happens in this scenario is, say for example, there is one employee table is there. In the employee table we can say, so what happens is that generally in the Golden Gate, not Golden Gate, in the data guard related scenarios, the archive logs will be moved to the target database in order to sync with the primary. So what happens is that whatever the information is available in the redo log files, that information is sufficient for data guard to replicate it to the target machine. But whereas in the data guard, whereas in the Golden Gate, whatever the information is available in the redo log files means this one or this one, that is not sufficient for Golden Gate or any replication tool to replicate at the target machine. So whatever the information in general available in these redo log files, that is not sufficient for target machine to replicate the changes. So for example, you did a change for employee table. Say for example, you changed one salary component of employee table from 5,000 to 10,000. So the same change has to be replicated over here. In general scenario, what happens is that whenever you make any changes, one change vector will be created in the redo log files. So this change vector CB change vector, what happens is that before image will be there. So before image is 5000 and after image 10,000. This entire information will be available. But in order to perform replication at the target machine, this information itself is not sufficient to track the record at the target machine. In order to track the record at the target machine, replication tools like it's either it in SharePlex or it is in GOLDGEN or in Streams. Replication tool requires more information to track that record. So, for example, I changed the value from 5,000 to 10,000 for employee number. Say for example 201 is there, one employee is there. For his we changed the salary from 5,000 to 10,000. Whereas in regular GOLDGEN, not GOLDGEN, that is data technologies, the changes whatever available in the redo log, redo log files or in the archive log files, so that information is sufficient. But whereas in GOLDGEN, that information is not sufficient to replicate a target machine. So, but how to achieve? What exactly additional information is required over here? So, in addition to this information from 5,000 to 10,000, we need to provide more information about this record. So, in order to trace this record at the target machine, we need to provide more information. So, that is nothing but some supplemental information we have to provide. So, that information will be made available in the archive logs by enabling the supplemental logging. That is nothing but a supplemental logging. So, before configuring any GOLDGEN or any replication tool, either in the source or in the target, the first step what we need to do is we need to enable the supplemental logging. So the purpose of supplemental logging is to add more information about the record which we are going to update. For that record, we are going to add more information for that record, so that replication tool can identify that particular record in the target machine easily. So for that reason, we will enable the supplemental logging. So what happens in the supplemental logging is, suppose if you enable the supplemental logging, what happens is if the table is having primary key value information will be stored in the redo log files or archive log files along with the other columns whatever it is updating. Suppose if the primary key is not available for that particular table, so what it include is unique value. Suppose if the table is not having the primary key and either a primary key nor unique values, what it does is that it will add all the columns available in that particular record. But this is going to be a very rare situation. It's also a common situation, but Oracle recommends to have primary key, either primary key or unique value in each table. While designing the database itself, you need to ensure that every table is having a primary key or unique key. But in the some situations, table may not have either ones. So in that case, what happens is GOLDGEN will capture all the columns irrespective of the columns which you are going to update. So suppose if the particular table is having 100 columns, but you are going to update only one column, still 100 columns will be captured on the source machine and it will be sent to the target machine, because it has to track the record correctly. So in order to track the record, what it does is it will try to add more information about that record in the supplement in the redo log files. So it will be easy for replication tool to identify the record at the target machine. So for that purpose only, we are enabling the supplemental logging. Supplemental logging will happen based on the primary key or unique value. If none is available, like the primary key or unique key is not available, then what it does is it will capture all the column information from the source table. I mean all column information about that particular record, whichever you are updating. Okay, so for example, you are updating one row. So what it does is that suppose if the primary key is available, means primary key information plus changes whatever you are doing, that will be updated. So suppose if you are updating 2 records, so what happens is that primary key information for 2 records, primary key for first record plus changes, primary key for second record plus changes. So those will be moved to the, not moved, those will be included in the redo log files. Redo log file means basically a redo log buffer, from there it will be moved to redo log files. So suppose if you are updating a record, which doesn't have no primary key plus no unique key. So what happens is that in that case, it will add all the columns of that record. Okay, not the table. For example, if you are updating about the employee whose employee ID is 201. In this table, let's say example, we have employee ID and employee name and address and date of birth and XYZ information is available, then salary is there. And you are updating only salary, but what it does is that since it doesn't have primary key, then what it will do is that it will record all the information, employee number and employee name, address and date of birth and everything. It will include into the redo log files, and this will be shipped to the target machine. And target machine will at the target machine replicate will use this entire information to identify that particular record. So for this purpose, I mean, in order to replicate any record at the target machine, the replication tool looks for more information that will be made available in the redo log files by enabling the supplemental logging. Then only you will have more information about the record, and that will be used while tracing the record at the target machine. Okay, so now how to enable that supplemental logging? Supplemental logging, basically it's a feature available at the database level, but we will not trace for all the tables. We will enable the supplemental logging for only those tables for which we are implementing the replication. Say for example, this is the source database and this is the target database. What we will do as a first step, we will enable the feature at DB level, and we will enable it tracing for, not tracing, we can say logging, we can say for required tables. So in this example, in the source database, we have sort schema. In the sort schema, we have 5 tables, we can say. Out of 5 tables, one is employee, another one is DEPT, third one is bonus, fourth one is sal grade, something will be there. Out of all these 5, we need to replicate only these 2 tables, employee and DEPT tables. So in that case, what we will do is, as a first step, we will enable the feature at a DB level, okay, and we have specific commands, and after that we will enable the trail logging for only those tables which we are replicating. Replicating means here we are replicating for employee table, another one is a DEPT table. So for these 2 tables only we are going to enable the tracing. For rest of the tables like bonus or salary grade, we are not going to enable the logging, because those are not being replicated at the target machine. Next question is, do I need to enable the supplemental logging at source and target also? Answer to this question is, it's based on your topology. Suppose if you are implementing unidirectional means what happens is source will be over here and target will be over here. Okay, so what happens is the transaction takes place only over here. So here this is only read-only table, read-only database. No transactions will take place over here. Only transactions takes place in the target machine. So automatically, source machine. So we need to enable the supplemental logging only at the place where transactions are taking place. So in unidirectional, what happens is transactions are happening in the source database only. So we will enable the supplemental logging at source only. Okay, no supplemental logging at target. Okay, so this is about the unidirectional. Say for example, in bidirectional, how we are going to implement? In bidirectional, what happens is that source will be there, target will be there. So what happens is transactions will take place at the source machine. So the transactions keep moving from source to target. In the same way, the transactions will take place at target machine also. So the changes whatever happening, that will be replicated to the source machine also. So in this scenario, we need to enable supplemental logging at source machine, and we need to enable supplemental logging at target machine also. Okay, so in this way we will enable that supplemental logging based on our business requirement and based on our topology. So suppose if it is a unidirectional, we will enable the supplemental logging at only source database. If it is a bidirectional replication, we are going to enable the supplemental logging at target machine also. I mean both at source as well as target machine. So, and why supplemental logging is, supplemental logging will help, add more information about the records being updated. So replication tool can easily identify those records at the target machine with the help of this supplemental logging. And the third point is how we are going to enable the supplemental logging. So enabling the supplemental logging is a two-phase process. The first phase is just we will enable the feature at the database level, and the second part is we will enable the logging for required tables only. Means in the first step we will enable the feature at the database level, means we are specifying to the database that we may use this feature as and when required in the schemas. Like that, just we will enable the feature. But in the second stage, for whatever the tables we are configuring the replication, for those tables we need to enable the supplemental logging. Okay, so suppose if you need to enable the supplemental logging for a particular employee table, what you have to do first at the database level, you need to enable the feature, then you can configure the supplemental logging for that particular employee table, then only the logging will take place. So this is about the supplemental logging. Let me give you how to enable the supplemental logging. Just I'm not writing. So for example, if my database has been enabled supplemental logging or not, just we will use this command. This command I am going to show you once I install the database in my system, so that you can able to see whether it is available or not. And this is the first phase point. And the second point is for enabling the supplemental logging, just we will execute this command, alter database, add supplemental logging. So once you execute this command, what happens is that database feature, that is supplemental logging feature, will be enabled at the database level. So once you run this command, just it is not going to happen any logging, just it enables the feature at the database level. So no additional information will be written by executing this command, just it enables the feature. Okay, and once you enable this feature, then while configuring the golden gate, what we will do is just we will enable the supplemental logging for the required tables. So this is the way how we are going to do, but I am going to show you when I'm doing the configuration at the golden gate. So the simple method is just add rand data, and we will specify the table. The table is like one table or entire one schema we can specify. I can show you that one. I will show you that one also. And this is the way how we will check what are the tables being for which we enable the supplemental logging. So this gives the information about the list of tables having supplemental logging enabled. And the other command, whatever I shown you earlier, is it shows whether my database is having supplemental enabled or not. So just to try to understand the difference between these two. This command shows whether my database at database level supplemental logging is enabled or not. It will show. And the other one is I think somebody. Okay, sorry. Okay, and the second one is it will show what are the tables for which tables we have enabled the supplemental logging. So this is about the supplemental logging. Okay, the next topic which I am going to cover today is installation of Golden Gate. So let me switch to other machine so that I can show you in the system itself. Before that, I need to give some information about the installation method, like the prerequisites and what are the points we need to consider it. And after that, I will show you where to download and which version we have to download and how to install, etc. I am going to cover today. Just let me take 1 minute. Let me configure other machine. Okay, I'm starting my virtual machines over here, so I think it may take a few minutes. In the meantime, I will cover the installation related points which are important, so that in the meantime systems will be available. Okay. The first step is where to download this software, GOLDGEN software I'm going to cover. And the second point is that what are the prerequisites we need to consider, like in terms of disk space, how much we required and what are the locations we need to configure. And the second point is memory requirements. Third one is the user's requirement. Fourth one is yeah, you can say privileges, whatever that comes into this user section only. So these are the important points. Out of all these, I think you may need to focus more about the user's requirement. Rest everything is a general concept. I think that's common for every software. There's not much importance of that. But we need to stress a little bit about the users and their privileges, how we are going to configure. So first of all, let me explain you from where we are going to download it, the software, and what are the versions we need to consider it. Okay. Currently, whatever the demos and whatever the concepts I'm explaining, those are based out of GOLDGEN 11G software. So I have, so far I worked in 11G software, but currently we have 12C also. 12.2 or something is there. So not much differences. 12.2 or something is there. So not much differences are there. Very few differences are there, which I am going to cover as and when time permits, and as and when we are discussing each component. So this 11G software or 12C is available in the site called otn.oracle.com. So anybody can download it for education purpose. And in otn.oracle.com, basically you will get only 12C software currently which is available in the market. So suppose if you need 11G software, you can go for edelivery.oracle.com. edelivery.oracle.com. So in either locations, for either locations, anybody can download directly. So you can use your own email ID and you can create an account in either of the sites and you can download the software. And the software will be less than 100 MB will be there. So it's nothing to worry about the space also. So only the thing is that which version you have to install. So that is the point which we need to consider it. Say for example, as I mentioned earlier, currently we have 12C software, 12.2 something is there. So which version I have to install in my machine? So basically what happened is, when Oracle, when GOLDGEN version at 10.4, Oracle purchased it. So this version is separate from the Oracle database version. So this is a GOLDGEN version. And if I'm having database version, I can have database version 11G or 10G or 12C. Anything can happen. Anything will be there at the database level. So we need to choose a GOLDGEN software which is compatible with the database that we have to choose. Suppose 10G is there. 10G, as per my knowledge, I think it can support up to 9i. It will support 10G. It supports, and 11G also supports. After that, 11.1 came. It also supported 9i, 10G, and 11G. And 11.2 is there. It also supports like that. Now 12C is also there. So this supports, I'm not sure about 10G, but it supports 11G as well as 12C. So these are the versions it is supporting. So this information, certification information, you have to check from Metalink. And accordingly, you need to choose which version you have to download, like whether it is a 11G version or 12C version you have to choose, and based on that you are going to download it. Yeah, system is ready, my other systems. So I'm transferring the present role to other machine. Okay. I have another laptop with me wherein I have configured virtual machines, two machines I configured over there. So now I changed my control. I changed the other laptop as a presenter over there. So I'm going to show all the demos from that machine only. The reason for using two laptops is that in the current laptop from where I'm giving the presentation, that can have access to my digital notepad, but other machine doesn't have the access to the digital pad, so I'm using my other the current laptop. So other laptop having virtual machines because it's having huge memory, like it was 16 GB RAM as well as 1 TB, i7 processor. So I configured all my servers on that machine. So that is the reason I'm using two machines for here. I hope everybody is able to see. So okay, now first step is I'm going to show from where we need to download the software, and we will ship it to, we will discuss about the primary requirements like users requirement as well as disk space and memory requirements in a brief way. Okay, first let me connect to the otn.oracle.com. For that I can use my current account, that Oracle info sharing. So in the downloads we have, just you can say, middleware. The Golden Gate will be available in middleware section. So in the middleware there is an option called Golden Gate. Just once you accept the license, see there you will see three sections. One is Golden Gate, and another one is mainly management packs. So this is the management pack, and third one is the Oracle Golden Gate. So these are the three main sections which we need to consider it. One is Golden Gate software, that is the binaries which we will use it for replication purpose. And there is another section called Golden Gate monitor, management pack. So this contains like monitor as well as director. And another one is Veridata. So in order to perform a basic replication on your machine, you need to install the first, you need to download the first section, that is Oracle Golden Gate only. This doesn't have any other tools, whatever I discussed in the first session, that is Oracle Veridata as well as Oracle Monitor. If you need those, you need to download from here. Okay, I will discuss about those later. The first point is that which version I have to download. So suppose if you are installing on Linux machine, you can use this one, Oracle Linux 64-bit. If you are installing it on Sun Solaris, you will use it. Accordingly, based on your requirements, say I am using Oracle database as a source as well as target. So I am going to use Oracle Linux on x86 64 machine. Suppose if it is some different platform in your machine, you can use your, accordingly you can download it. So I created separately for this purpose Oracle info demo. So from there, I'm downloading the software. So this is about the location from where we can download the software. And here I started downloading 12C. However, if you need older versions also, you can download it from edelivery.oracle.com. So that is available from here. I think the same account will work for both the accounts. Oracle Golden Gate, if I give that, So I have a mission, Linux mission, so I'm choosing it as a Linux. So selected mission is Oracle Golden Gate and platform is x86-64. If I need older versions of Oracle Golden Gate, say for example 11.2, and this is Oracle Golden Gate, Oracle standard terms, and this is okay, and the size is approximately 260 MB, and it's very small actually as compared to Oracle software. Just you can do that. So it will ask for some agreement. Just say yes, you will do default. We will do that. So we have two versions. Either one we can make use of it. Just I'm picking up the latest version. So that is getting downloaded. Okay, let it continue over there. So in the meantime, I will explain about the like what are the OS requirements we need, and as well as Oracle user and I mean users required for installing the Golden Gate. And users related component is little important to understand. Space requirements, those are nothing. So let me come back to my original mission. I'm trying to take the control. Okay, perfect. Okay, so I'm going to cover two topics now. One is OS requirements, another one is the users requirement. OS requirement is like disk space. So what are the spaces we need to consider? And the second one is memory. Third one is users requirement. So let me cover about the disk space. In the disk space, we need first one is some space for software, some space for temp location. Third one is location for trial files. So these are the three things which we need to consider. The software will be hardly less than 100 MB will be there. Generally what we used to do, just we used to allocate 1 GB of space as a buffer, and for installing the software and retaining the zip file, and if anything is required also will be there. We can make use of. /tmp is one more important directory over here. It's similar to our regular software. What happens, as I mentioned earlier, extract will keep tracking all the transactions from redo log files. So all the transactions, whether it is a committed transaction or uncommitted transaction, it will capture into its local buffer. And if any transaction is committed, it will send to the trial file or remote mission. So this is the combination we discussed. So suppose that means there will be some entries left over here, those are not yet committed. Okay, and this is a local buffer to my extract process, and this could be very small in size. and it cannot hold all the transactions, but at the same time there will be some uncommitted, non-committed transactions will be there in this buffer, and it has to hold those transactions till those are committed or rolled back, because those will not, these transactions will not be available anywhere else later. So as and when the transaction takes place, and those will be moved to the redo log files, after that subsequently those will be moved to the archive log files, and extract keep monitoring at redo log files, and as and when it sees any transaction, it will read that and it will place into this buffer. As and when a particular transaction has been committed, those will be moved to the trail file. So this is the process. So this extract has to hold that non-committed transaction for a while. At the same time, database keeps sending the transaction changes. I mean, the redo log files keep getting the changes. So it has to hold this transaction for a long time. So in order to hold those transactions for a long time, what it does is that when the when the local buffer is filled, it will send to swap space, which will be created in our temp directory. So this is the use of /tmp in Golden Gate. So what happens is that as and when local buffer for that extract is filled, the non-committed transactions will be pushed to the some swap space, which will be created in /tmp. Generally, this location will be in the Golden Gate directory only. So I'm going to explain it when I'm going to install the software. When I'm installing Golden Gate software. So this is about the temp location. The third point is location for trail files. So this is very, very important. You have to allocate sufficient space for the trail files. Say for example, okay. This is a source mission. What happens is that a transaction taking place over here, and all those will be available in redo log files. There automatically will be moved to archive logs. Our extract process is there. So what happens is that in order to decide the size of the trail files, basically we need to retain trail files in the source location for a certain period. Either it could be 1 hour, or whether it could be 2 hours, whether it could be 1 day, based on the design and based on our business situation. Okay, so some people will keep for 1 hour, some people will retain for one day the trail files in the source mission itself. So this is the source mission. So accordingly, you need to allocate the space in the source mission for retaining the trail files. So the general formula is this is the formula which we can make use of it. Total trail disk space is log volume in 1 hour. Log volume means 1 hour means. So this is the redo log files. How much redo we are generating for 1 hour, we have to calculate it. So into what we need to do is that multiplied by number of hours downtime tolerable for our machine. Say for example, basically we can say it's a company decided policy. Okay, you retain it for 5 hours of trial files in the source machine. Somebody will say 12 hours. It's based on our business situation, we can say. So suppose if our business agreement is that we need to retain the trial files for 10 hours. So for example, 10 hours means for each hour, if we are generating 2 GB of redo log files and we need to hold for 10 hours. So means what happens is that 20 GB we need to retain, 20 GB we need to allocate in the trial files. But Oracle given a solution for this is multiplied by 0.4. So means it comes approximately 8 GB. So 8 GB of space we need to allocate for, sorry, I think I'm not sure. Yeah. So 2 GB is there for 1 hour. For 1 hour, it is generating 2 GB. So 10 hours downtime is acceptable in our environment, and 10 hours is the agreed time with the management. So how much we need to allocate space for trial is minimum is 20 hours into 0.4. So this is the Oracle provided formula. So it comes to 8 GB. So 8 GB of space we need to allocate on the source machine. So we can hold the trail files for 10 hours continuously without having any issue. But this is an estimation also, but we need to keep monitoring the space. Sometimes the transactions will be more and sometimes very less. So we, initially we will start putting it from this basic formula, but as and when a transaction keep happening, we will keep monitoring and we will adjust the trial files location. So this is about the disk space. So total we discussed about the 3 points. One is software location, and another one is the trail file location. Third one is the /TMP. This is about the disk requirements, and second point is that memory requirements. Okay, so the memory is a little important concept over here also. So if you see that machine, Golden Gate configuration, so we are not configuring all the components in each machine. Say for example, in unidirectional, what we are doing is, this is the source and this is the target machine. We are configuring only manager over here and extract over here. Here we are configuring manager and replicate we are configuring. In the source, optionally data pump we are configuring. So that means based on our business requirement, we are configuring the components. So accordingly, we need to size our memory also. Generally, for each component, either it is a manager or extract or pump, it requires approximately 50 MB of memory required. Actually, they given it as a 25 to 50. Just let's take it as a higher value. So that is 50 MB is required for each manager process. Say for example, my source machine is having one manager, two extracts, let's say example, two extracts and two pumps. So accordingly, I need to size the memory for this machine. Say for example, this 50, 100, again this 100. So 250 MB of memory I need to ensure that this is allocated for our Golden Gate requirements. In the similar way, in the target machine, one manager and two replicates. Let's take an example. So one manager, another one is two replicates. So this is for 50 and this is 100 MB. So total 150 MB should be made available for Golden Gate at the target machine. So this is the configuration, this is the calculation we need to do initially for Golden Gate. And the second point important, I think people may ask in interview, but in real-time scenario, we generally, we will not have this much number, but just as an information I'm telling you, maximum we can have 300 extract or replicate processes in any Golden Gate environment. We will not reach this number, but general idea for a general purpose I'm telling you. In any mission, in the source or in the target, we can have maximum 300 processes. Either it could be extract or replicate or both together we can say. Plus one manager will be there. So this is the limitation for this is the limit currently set. And apart from that, one GGSA prompt can support up to 5,000 processes information. Okay, but we can have up to 300 processes only, extract or replicate processes on any single Golden Gate environment. Say for example, I have a source machine over here. I have a target machine over here. So these are the two machines over here. So we need to install Golden Gate over here also, and we need to install Golden Gate over here also. Here, based on requirement, we can configure up to 300 processes. Either it could be extract, or it could be replicate, or pumps we can say over here. Here also, maximum we can configure up to 300 processes, either extract or replicate or pump processes based on our requirement, based on our business. This is the maximum limit. Okay, so this is about the, so based on this number of processes, we will allocate the space memory for that machine. Okay, so this is about the memory, and the next topic is users requirement. This is a little important. Just try to understand all these points in this. In Golden Gate environment, we will have two users required for any mission. Let me use this one only. Okay, so this is the source mission and this is the target mission. For example, in the source mission, we need to access the log files available created by the source database, and it has to push it to target mission. This is the basic flow happens in any Golden Gate environment. For this purpose, we need to have total two users. One is OS user, another one is DB user. These are the two users required at any configuration, either it in source database or in target mission. In the source database, we need OS user as well as DB user. So now we are going to focus what are the privileges required for OS user and what are the privileges required for the database user. As I mentioned earlier, in the source, we will have extract. It keeps monitoring redo log files generated by the source machine. So these redo log files generally owned by Oracle user, Oracle OS user, and this is owned. This OS user owns the software also, and this OS user is a part of O install group. So whenever any redo log file will be is getting created, that redo log file will be owned by Oracle user, and this Oracle user is a part of O install group. So the redo log file will be owned by Oracle user because Oracle owner is owning the Oracle software. At the same time, database will be created from the Oracle user. So what happens is that redo log files will be created with Oracle as a user, and this Oracle belongs to O install group. This is the O install group. So in order to access these redo log files, the other user also should have O install group as a member for them. Say for example, if I need to access these redo log files, the user, whatever the user we are using for Golden Gate, that user also should have O install as one of their group. So in nutshell, what we can say, Golden Gate should be installed, Golden Gate owner should be a part of O install. So generally what we will do, we will install the Golden Gate software in Oracle software owner only. But at specific cases, we can install it with a separate user. If you are installing with Oracle user, then there is no need to worry about O install or anything because those are already configured. So nothing to worry. If you are using Oracle user means from where in which user you already installed the database software. Okay. However, if you are installing it from different user, for example, you need to have separate user for Golden Gate software means you need to have O install as a group for that particular user. Say for example, GG user is the user you decided, GG user. GG user. This user should be a member of OInstall group. So this is the requirement for OS. So apart from that, rest everything is same. Okay, so this is about the OS user. I hope everybody is clear. Okay. And the second point is database user. Oh, sorry. Another one. Yes. Okay. And the second point, I need to give you one more point here is that this redo log files, I hope everybody aware of it. These could be available at local file system or in ASM environment. For ASM environment, we need to take a little additional steps while configuring the replication. Okay, so at this moment I am not talking about those. I will explain you when I am talking about the whenever I'm configuring the extract configuration in the source machine. So, but ultimately, user should have access to the read log files. So that is the baseline we can say. Okay, let's move on to the database user. We need to have a separate Golden Gate user either in the source database or in the target. In both the locations, we need to have a separate user for Golden Gate through which all the transactions will be accessed and all the actions will be done with that Golden Gate user only. For connecting to the database also, we will use the Golden Gate. For enabling the transaction log, supplemental logging for any particular table, we will use the same database user. OS user we are using for installing the Oracle Golden Gate software and for reading the read log files. Whereas database login, we will use it for making the changes at the database level and enabling the transactions and for reading any content in the database. For that purposes, we will use the database user. For that purpose, we need to have a separate Golden Gate user at the database level. So whenever you are configuring the replication, you need to create database user at the user at the database level on source as well as in the target machine, and that particular user should have access to all the tables for whatever you are planning to replicate. Generally, if the company is okay, we will give as a DBA privilege to Golden Gate user. However, if the company is restricting not to give DBA privileges to Golden Gate user, there are specific privileges. I will show you those privileges also. Those privileges we need to grant it to Golden Gate user. Then only you can able to perform the replicate. Okay. So this is about the users. So one is at OS level, another one is database level. OS level, that should be a part of OInstall group, and suppose if you are configuring from Oracle user itself, no additional steps are required. But if you are configuring from a different user, say GG user or something, that user should be a member of OInstall group. Okay, and the second user is a database user. Database user is required for performing all the database related transactions, like enabling the tran log, or for replicating the changes at the target level, or reading the checkpoint table. For all the purposes, for at database level, we need to have one database user. That user should have certain privileges, like select any table or update any table, etc. There are list of privileges are there. Those has to be granted. In short way, we can grant DBA privilege. But this is based on your company policy. Either you can grant DBA privileges, or you can grant. You can grant DBA privilege, or you can grant specific privileges based on your company policy. And the next one is okay. Next, I will give a brief idea about the software installation now. Next week we'll start with the Golden Gate installation only. Okay. So software installation, just I would like to cover 2 points over here. How we are going to install it in 11G, how we are going to install it in 12C also. So just I will give you overview. I think it's already 9 o'clock your time. Just I will take another 5 minutes maximum, 5 to 10 minutes maximum. So we can wind it up today. In 11G, the software installation is very, very simple. Just unzip the software using your utility like unzip or gunzip, something is there. No? So you can use any of the tools and you can uninstall it in any particular location. So that is nothing but a Golden Gate installation in 11G. Whereas in 12C, and sorry, another step is that we need to create a folders. Approximately 8 folders we need to create in Golden Gate location. So these are the 2 steps which we are going to perform in 11G. So the first step is unzip the software, whatever the software you downloaded it from the Golden Gate, otn.oracle.com, and you will transfer the file to Oracle server and you will just unzip the file. That's sufficient. So second point is that folders, that will be called as the subdirectories, we can say. Those subdirectories you need to create in the Golden Gate folder, Golden Gate software location, and that is the second step. So in case of 11G, you need to follow these 2 steps. But whereas in 12C, Oracle, clubbed with Oracle Universal Installer, OUI. In this OUI, just you will unzip the software basically, and you will run the run installer. Automatically, it will take care of both the steps. Placing the software in unzip means just you will place it in one particular folder, as well as creating the subdirectories. These two steps will be covered by OEI tool itself. You people might be aware of OEI is a standard tool for all Oracle installations. So Oracle is trying to bring this Golden Gate also into standard method using OEI. So in 12C, what we will do, just we will run this OEI Oracle Universal Installer. Automatically it will install 12C software in your machine. So as a part of itself, as a part of that installation itself, the subfolders also will be created. Whereas in 11G, there is a specific method for creating the subfolders. Using that method, we will create the folders in 11G. So both are very simple, hardly takes 5 to 10 minutes. Okay, so which I am going to cover in the next session. Okay, so today I am going to wind up at this point. Just before that, just I would like to give you one brief idea, whatever the topics we discussed. Today we discussed about the Golden Gate various topologies. So we discussed about the 6 topologies, whatever commonly available. And second point is supplemental logging. So why we required is supplemental logging is required in order to track the records at the target machine. So we will enable at the source machine. So Oracle will add more information while updating any changes. So this supplemental logging will be used for update as well as delete statements only. So whenever you are performing any update or delete statements, in addition to regular information, it will add more information about that particular record. So the replication tool can easily identify that particular record in the target machine. So this supplemental logging we will enable only in the source machine in case of unidirectional replication. In case of bidirectional replication, you will enable the supplemental logging at both source as well as target machine. And enabling the supplemental logging is a 2-step process. We will enable the feature at the database level, and the second step is from the Golden Gate tool, we will enable the logging for that particular records. So this is about the supplemental logging. And third point, we discussed about the Oracle installation. We discussed about the memory requirements, and before that we discussed about from where to download, and second point is where to what are the disk space requirements and memory requirements, and the third one is users requirement we discussed. And in the users requirement, in the memory requirements, each process like extract or replicate or manager process, any process, each process requires approximately 50 MB. The Oracle standard is 25 to 50 MB, but I am taking it as a higher level, higher end value, that is 50 MB for each process. So suppose if you are configuring one extract, one data pump and manager in the source means you will have three processes. Three processes means 3 into 150 MB. You need to ensure that it is available for the golden gate in the source machine. In the similar way, target also you need to configure. And maximum we can have up to 300 processes. Either it could be extract or replicate or data pump in the source, as well as in the target also the same limit is applicable. And third one is users requirement in the for golden gate software. There are two users required for golden gate. One is OS user, another one is the database user. OS user should be a part of OInstall group because it has to read redo log files generated by the database. That is the reason the user from where we are installing the golden gate, that should be a part of OInstall. If you are using Oracle standard user, so no need of worrying about the OInstall group because it's already part of OInstall group. But if you are installing golden gate from a different user, you need to have a separate user. If you are installing from separate user, means that user should be part of OInstall group. And next one is the database user. Database user is required for in order to perform the replication and reading the tables, etc. That user should be should have specific privileges like select any table or update any table, etc. And in a simple way, we used to give it as a DBA privilege so that all the privileges will be available. There won't be any problem. But it's completely based on your company policy. If company allows you to give a DBA privileges to the user, you can give. Otherwise, you need to specify the specific privileges. Those privileges I will share you when I am configuring the user. So that's all about today's session. So next session we will start with the golden gate installation and we will configure the users, and after that we will start with the initial chain synchronization. Okay, so I'm stopping the record now. If any doubt, just you can mail me.